All right, so the next chapter starts with factoring. So I don't know how many of you are familiar with factoring or not. You guys know what it looks like, the term FOIL. You know I hate that word, right? But you know what that is. So factoring is taking the answer that you got when you multiplied them together and taking it back to the two sets of parentheses. That's what factoring is. But before we factor, just like I always yell at you guys to simplify first, we do the same thing with factoring. That's why I want to kind of real quickly just take a few minutes and go through with you guys. So it's called factoring out the greatest common factor, or the GCF. So what is the greatest number that goes into 6 and 8? 2. Good. That's the biggest number that divides into both. Okay, what's the biggest number that goes into 12 and 20? That is 4. What about 24 and 36? Bigger. It's 12. All right, now some of you can look at that and you're good with your numbers and you just know. And then others of you look at that and are like, how on earth did they know that? Okay, it's a long, tedious process, but if you're not sure, one of the things you can do is make we do factor trees, right? We don't want to do a huge factor tree, but we can look at what do you multiply? So always start with the basic, I know this is 1 and 24, have a nice organized list, right? I can go 2 and 12, 3 and 8, 4 and 6. All right, and then 5 doesn't work, and then I'm kind of climbing back up my list of numbers. Same thing with 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't, and then I'm at 6 and 6, and then you can kind of see my list goes back. So it's a very obnoxious process, but if this works for you. So then I look at what is the biggest number that's the same in both lists. It's 12. Yeah. All right, 12 is the biggest number that shows up in both lists. So that is your greatest common factor. Again, those of you who are fairly decent at your multiplication can probably just look at those numbers and know. Okay? All right, so that's finding the greatest common factor for just plain numbers. So what about when I throw variables in? This always throws people. So what about between 2x and 6? What's the greatest thing that's common to both? Just 2. Why is there not an x involved? Yeah, the 6 doesn't have one. Okay? What about between 3x and 12x? 3x. 3 is the biggest number that goes into both, and they both have an x. What about between 8x squared and 20x? It'd be 4x. Good. 4 is the biggest number that goes into both. And then why is it not x squared? It doesn't have an x squared, right? This is a really terrible analogy, but I have 3 kids, right? So let's say they all did something together, they all got in trouble. Now, I want to punish them, but it's got to be fair, right? I can't look at my one child and be like, I'm going to take 6 of your stuffed animals away from you. But then if this child only has 3, is it fair that I take 6 from this one and only 3 from this one? Is that fair? It's not fair. So what you want to do is you want to take as much as you can. I'm a mean mom, right? I'm going to punish them and take as much away from them as I can, as long as I can take the same from all of them. That's the big idea. So the variable one that usually kind of gets people, because they're like, well, I want to take an x squared, but that one doesn't have an x squared, so you can't, because I can't take it from all of them. Okay? This is Algebra 1. This was Chapter 6 when I used to teach Algebra 1. All right, so factoring out that GCF then is kind of like undistributing, right? Like normally if I would give you 2 times 3x plus 4, your response would be to distribute, right? You'd multiply that in and get 6x plus 8. So now it's like I'm giving you this, and you have to take it back to that. So instead of multiplying, what's the opposite of multiplying? Dividing. So, but first you've got to figure out what is the greatest common factor. So between 3x and 15, it's the biggest number that goes into both. 3. Can you take any x's away? No, because that one doesn't have an x with it. All right, so that is your greatest common factor that I factored out. And then you have to divide to see what you have left. So what's 3x divided by 3? It's 1x, or just x. There's a plus. And then 15 divided by 3 is 5. All right, so that is factoring out a GCF. How many of you, show of hands, have done that at some point? Okay, that half the room. All right, like nobody over here. All right, now the biggest thing that drives me crazy when students miss these is, can you check every answer? Yeah, 3 times x is 3x. 3 times 5 is 15. Yeah, it worked. Okay, the other thing to look for, whatever you have left in here, if there's still a common factor here, like a 2 would both go into these or something like that, that's a red flag. That means you didn't take out the biggest thing. So you always want to kind of just do a little look on that. All right, what about the next one? What's the biggest number that goes into all 3 of those? 18 divided by 4. Yeah, it's just 2. Can I take an x from them all? No, because that last one doesn't have an x. Okay, so if I take out a 2, and if it helps, go ahead and write the divide by on all of these. I may do that for you for a while, then eventually I'll just stop doing that. But what you're doing is you're dividing them all by whatever it is you're taking out. So 18x squared divided by 2, 9x squared. Good, minus 4x, minus 6. Perfect. Now again, that mental check, does something still go into 9, 4, and 6? No. If something would have, that'd been your indicator that 2 wasn't the biggest thing. Okay? Okay? Next one. What goes into all of those? Can I take a next? Nope, because that last one doesn't have one. All right, so take out a 3, which means I'm dividing all of these by 3. And what do we have left? (5x squared) plus minus 4. Good. How was this process? Are we okay? Making sense? All right, let's just look then what happens when you have variables with them. Just making sure we're okay and taking some variables out. So 15x cubed plus 27x squared. First look at numbers. What goes into 15 and 27? 3. This one has an x cubed, that one has an x squared. So how many x's can I take? Squared. 2 x's or x squared. Okay, so then we're going to divide this out. Divide them both by 3x squared. Okay, and then what do we have left? Yep, 5x plus 9. Now think back to the test you just took. What are your exponent properties? If there were 3 up here and 2 down here, what did you do with those exponents? You subtracted them. Or just think of it as, this is 3 x's, I'm taking 2. How many's left over? There's only 1 left over, so it's just an x. All right, 24x to the 4th minus 8x cubed plus 32x squared. What is the biggest number that goes into all of them? Ooh, good. A lot of times people tell me 4. It is 8. And how many x's can I take? X squared. Because they all have at least 2 of them, right? You have to be able to take it from all of them. So again, divide out the 8x squared. And what do we have left? Very good. Can you do this when they have more than one variable? Yeah. Sometimes you can just take more stuff. So again, look at numbers, 20 and 35. I can take out a 5. Okay. How many x's can I take? 1. How many y's can I take? 1. Because again, I have to be able to take however many you're taking out. I have to take it from both. Okay, so that means you're dividing out 5xy from both of them. So what's 20 divided by 5? That's 4. I had 2 x's, I took 1. Got 1 left. And then the y's? The y's are gone. 35 divided by 5? 7. Good. And then a y squared. all I wanted to cover today. How are we feeling? Okay, majority of you, I think, majority of you have learned this before.